How do you factorize 3x squared plus 6x? It's quite useful if you split it to show that this is 3 times x, and then 6x. So 3x squared is 3 times x, 6x is 6 times x. Now, let's take one out. We know that there's an addition in the middle. So we know 3 can be factorized. If I factorize 3, the first bracket will be left with 1. So I'm going to put 1 there. Second bracket will factorize 6x. Let's split that even better. Let's say 6x is 3 times 2 times x. So if 3 is taken out, I'm left with 2 here. And then I can also factorize x. So factorize x there. So in the first bracket, I'm left with x. The second bracket, I'm left with just the 2 because x has been factorized. So rewrite this. This is 3x multiplied by x plus 2. You can always check your answer if it's accurate. Multiply this in again. 3x times x. 3x times x is 6x, 3x squared. And 3x times 2 is equals to 6x. So you know your answer is correct. Number 2. So 8 is 4 times 2. X, y. 2x is 2 times x. Y squared is y. So you can see this quite clearly. Now obviously you know you can factorize 2 out. So you've got 2. And then you can factorize an x and a y. And x and a y. So I've got x, y. What am I left with? So the first term here, I'm left with 4x. The second term, I'm left with y. So that's quite easy. Let's just check. 2xy times 4x gives me 8x squared y. 2xy times y gives me 2xy squared. So we know this is accurate. Now for factorizing the next part, you just need to recognize that this is actually difference between two squares. So difference between two squares. What do I mean by difference between two squares? Now, if I were to write this out carefully, so this is x squared and 1 squared. They are the same. So x squared minus 1 is the same as x squared minus 1 squared. So if you have got two squares and you have a minus in the middle, it is a difference between two squares. Now you then use this particular method to write your answer. There's a minus, there's a plus. So x squared and 1 squared. So x here, 1 here, 1 here. So your answer is x minus 1, x plus 1. Exactly the same method here. Can I write this as a difference between two squares? Looks like I can write this as 3p. So 3 squared is 9, p squared is p squared. So this 3p bracket square is the same as 9p squared. And of course, similarly, this is 4q squared. So if I have the difference between two squares, I have a minus, I have a plus. So 3p squared in bracket, so that must be 3p there and 3p there. 4q in bracket square, so that must be 4q, and this is 4q. That's your final answer. Now be careful with part C. It looks as if, it's a difference between two squares, but it's not quite, because you need to first factorize 3 out, because 3 is a common factor. So you just need to recognize that if I factorize 3, I've got x squared in the first term, and 75, I've got 25y squared. So now I can now write this as difference between two squares. What are they? It is x in the first bracket, 25 in the bracket, it will be 5 squared, and then this will be 5y. So you end up with two brackets there. If it's difference between two squares, one of it is negative, one of it is plus, that will be x and x, that will be 5y and 5y. That is your final answer. And the very last one is, can you simplify this? So every time when you see a quadratic and a algebraic fraction, if they ask you to simplify, you always think factorize. So if I have x squared minus 36, I know that's x squared minus 6 squared. So that must be x minus 6, x plus 6. That is the difference between two square method. And now 5x plus 30, I can factorize x. I've got x plus 6. Now, so really nicely, you can see there's a bracket at the top and the bottom that you can cancel down. And that leaves you with x minus 6 over 5. That's your final answer.